Hello everyone, welcome to the video lecture series of inverse Laplace transforms. My name is Mayur Gohil. Today I will be guiding you with Laplace transforms of derivative of a function. So let us see what it is. We are aware that Laplace of f of t is phi of s. Then Laplace of f dash of t is nothing but s times phi of s minus f of 0. As well, Laplace of f double dash of t is equals to s square times phi of s minus s times f of 0 minus f dash of 0. In general, we do have one formula for the nth order derivative, that is, Laplace of nth order derivative of the function f of t is nothing but s to the power n times phi of s minus s to the power n minus 1 times f of 0 minus s to the power n minus 2 times f dash evaluated at 0 minus and so on up to minus of s times n minus 2th derivative of the function f evaluated at 0 minus n minus 1th derivative of f evaluated at 0. It appears very long formula, but there's an easy way to remember this. Let us see that way. See here, it's the only first term in which phi of s is involved. Phi of s is only in the first term. Then observe that the power of s goes on decreasing by 1. S to the power n, then s to the power n minus 1, s to the power n minus 2, and so on up to s to the power 0. Since nothing is here, that means there is s to the power 0. Okay. Now, observe the functions over here which are evaluated at 0. It is the first function is evaluated at 0, rest all other functions are having the derivative. So it is first derivative, second derivative, third, and so on up to n minus 1th derivative, which is just one less than the derivative of the original function that we are talking about. Okay, so this is the formula. So try to remember this general formula, then you can remember all the simple version also, but keep them in mind and we will recall it again. Okay, now these formulas are highly used in solving differential equations. It reduces your work of solving differential equations. So let us see. First of all, linear differential equations we are going to see here. So while solving linear differential equations, we will be using them. Let us see what are linear differential equations. This equation is a linear differential equation. D square plus d minus 3 of y is equals to 0 times, whereas y of evaluated at 0 is 1, okay, and then y dash evaluated at 0 is 2. These are the conditions to the differential equation. These are called as initial value conditions. That is why this differential equation is known as initial value problem. Okay, so we will not enter into great detail of that, but yeah, sometimes it is needed. So what is this differential equation talking about? Let us understand. First of all, what is this d? This d is equals to d by dt or d by dx, whichever is the independent variable, accordingly you write it. So over here, t is our independent variable, so I will be talking about d by dt. So what is the meaning of d square? The meaning of d square is d by dt of d by dt. That means it is d square by dt square. Okay, so this d is nothing but the operator. Okay, so now you are going to see it as an operator. Now when it operates on y, when this d square operates on y, it gives you your term d square y by dt square plus when the d operates on y, it gives you dy by dt. Now this 3 is just a constant number, so it will be just 3 times y. Okay, and the signs remain as they are. So this is the meaning of your differential equation given in this form. Okay, now what are these conditions talking about? Let us try to understand that. The meaning of this condition, the first condition that you see, y of 0 is equals to 1, it is nothing but y evaluated at t0 times 0 is, or the first t naught is nothing but y naught. So what is the t naught over here? It is t0. Okay, that is the meaning. And what is y0? It is 1. So you compare it, you get the values. What is over here? The meaning is y dash at t0 is y1. That means t0 is 0 and y1 is 2. Okay, are you getting that? So all these conditions have their meaning, and this differential equation also has its meaning. So let us try to understand and try to solve it. So let us take up this simple problem. We are going to solve it using Laplace transform method. Okay, so the solution, first you write let y equals to f of t. Now what are we aware regarding f of t? That is, Laplace of f of t is phi of s. Okay, great, we are done halfway, I guess. So now, not even halfway, let us try to go ahead. Yeah, so consider the differential equation, that is d square y by dt square plus 2 dy by dt minus 3y is equals to 0. You operate Laplace operator on both the sides. Now remember that Laplace operator is a linear operator, so the constants would come out. It would look like this. Laplace operator operated on the first term, then the 2 will come out, plus 2 will come out, okay, and Laplace would operate only on dy by dt, minus 3 would come out, and Laplace would operate on y is equals to 0. Laplace of 0 is 0. Okay, now recall the formulas that I asked you to remember. That is, Laplace of f dash of t is equals to s times phi of s minus f of 0, and Laplace of double derivative of f of t is nothing but s square of phi of s minus s times f of 0 minus f dash of 0. When you recall this, you have to remember that your dy by dt is nothing but f dash of t, and your d square y by dt square is nothing but f double dash of t. That is why we are writing this statement. If you understand it, just observe this statement. If you take double derivative, that means it's the double derivative of y. And when you take the derivative over here, it means it's the derivative f dash and dy by dt. Right? So you just have to understand the logic of the notations and you have to write it. So over here, Laplace of double derivative of y, when you do, you have to write this formula. So when you write that formula over here, this is what you are going to get. Okay, so we are done. After writing the formula, you write down the values of the f of 0 and f dash of 0 from the corresponding conditions that are given. So f of 0 is 0 and f dash of 0 is 4. Okay, I just explained you in my previous slide. So substitute that values. On substituting that values, you will get this equation. Okay, and it's just one step ahead. After this, you collect the like terms. On collecting the like terms, you obtain this step, that is s square phi of s plus 2s times phi of s minus 3 times phi of s minus 4. And then you collect phi of s and you will be getting this step finally. That would be phi of s is equals to 4 over s square plus 2s minus 3. Okay, having done that, you can either write this as a factorized, denominator can be factorized, or you can complete the square. Over here I am going to complete the square. I am writing it as 4 upon s plus 1 the whole square minus 4. Okay. So on completing the square, I obtain this. This is Laplace of f of t, right? This phi of s, just see there. It's Laplace of f of t. If I take inverse Laplace over here, I obtain f of t is equals to L inverse. That means it will come, that inverse sign will come on the other side, and I'll obtain 4 over s plus 1 the whole square minus 4. Okay. Now what is the thing? Observe here, there is a shift. Now if you can understand this lightly in advance, it is important. See here, this is a Laplace of some standard function, if you can observe it. If you have your formula list ready with you, it is nothing but some standard function related to hyperbolic functions, right? So here if you observe, I am going to do a adjustment here. This is the shift over here. So the shift I am taking care by e to the power minus t. And I now understand that this is the inverse Laplace, or it's the Laplace for some standard function, hyperbolic sine function, right? So the formula of hyperbolic Laplace of sine h at is nothing but a over s square minus a square. So it is over here, if I see, a square is 4 square, right? 2 square. So 2 square, when I write over here, I need to have in the numerator 2. So I'm splitting up this 4 as 2 into 2. When I split it up, I get 2 times e to the power minus t, L inverse of 2 over s square minus 2 square. Having done that, I obtain f of t is equals to 2 times e to the power minus t times hyperbolic sine 2t. Okay. And finally, I obtain y is equals to 2 times e to the power minus t into hyperbolic sine 2t. That's my final answer. Done. So the basic goal of solving the solving the differential equation using Laplace transform is to find the y, or f of t. Okay. So I have found the value of y. Okay. Now here some practice problems are there for you. These are 3 practice problems. They are all on the similar lines that I have done just right now. You can solve them on your own and revert back to me if you have any difficulties regarding them. Okay, so that's it for today. Thank you.